Hello. This morning I'd like to discuss, hello. I'd like to discuss a simple analogy that I've used in my classes to help students understand reaction orders. For a given chemical reaction, let's say simple A going to B, if the reaction is zero order, the rate of the reaction, which is defined as minus the change in the concentration of A divided by the change in T, the rate of the reaction, is a constant. Or you can say it's equal to K times A to the zero power, because anything to the zero power is 1. So if you have a zero order reaction and you double the concentration, the rate would not double, it would stay the same. Now another possibility is a first order reaction where the rate, defined the same way, is equal to K times A to the first power. So doubling the concentration of A would double the rate. Tripling the concentration of A would triple the rate. And then there's a second order reaction, and in that case, the rate depends on the second power in A. Rate is equal to Ka squared. And here, if you double the concentration of A, you would quadruple the rate of the reaction. If you tripled it, it would go up ninefold. Now for a third order reaction, let me center this, which are kind of rare, where it's third order in one particular thing, but the rate depends on the cube of the concentration. So doubling the concentration of A would make the rate go up eightfold. Now the analogy that I like to use is a cube. A cube has various properties. It has vertices, it has sides, it has surface area, and it has volume. Well, the number of vertices is equal to 8. And it doesn't matter what the length of the cube is, every cube will have 8 vertices. So it's an example of a zero order relationship. The rate or the number of vertices is equal to 8L to the 0 power. We could talk about the length of the sides of the cubes. Well, there are 4, 8, 12 sides, and each one has a length L. So the total length of the sides is 12L, or 12L to the first power. All right. So that's an example of a first order relationship. We could talk about the surface area. Well, the surface area of each side is L squared, and there's 6 sides. So the surface area is 6L squared, which is an example of a second order relationship. And finally, the volume is equal to 1L cubed, and that would be an example of a cubic relationship. So if we double the size of the square, if we made L doubled L, the number of vertices would stay the same. We doubled the length. If we doubled L, the length of the sides would double. We went from 1 cubic centimeter to 2 cubic centimeters. It would go from 12 to 24. If we doubled the length, the surface area would quadruple. All right. And if we doubled the length, the volume would go up eightfold, 2 times 2 times 2. So this is a nice, simple analogy to help students understand reaction orders. So thank you for your attention. I hope this is useful, and I'll see you next time.